Okay, so we are recording now. Yes, what other example do you have of vectors?
Velocity.
Velocity, okay, yes. Velocity is actually a vector, while speed is a scalar. Okay, that's the magnitude of velocity. Okay. All right, so I have the file of instructions in front of me for today's lab 2 vectors. And on the first page, there are mistakes. Okay, there are typos. Okay, can you all open it? Because so that we all follow the same file, the same instructions. On the first page, you have that the horizontal component of the vector A, which is AX, is A times the sine of the angle theta. Okay, that's incorrect. It should be A times the cosine of the angle. Okay, and then the vertical component is given as AY equals A times the cosine. So that's also incorrect. That's A times the sine of the angle theta. Okay.
Sorry, where are you reading from?
The file, it's posted
Professor?
on Blackboard. Let me see Blackboard. No, it's not on Blackboard. Sorry about that. I gave you a link. If you go to your Blackboard page, okay, in the subfolder corresponding to our course, there's a link for the to the instruction files in red. Okay. For some reason, I can't access that link. Do you all have access to that file? Okay, somebody just posted it in the chat room.
You said the horizontal and vertical components, sine and cosine, were switched?
Yeah, they switched. Well, no, so horizontal is, its name is AX, that's correct. And horizontal, its name is AY. Okay, yeah. But for the horizontal, you should have a cosine. Yeah. And for the vertical, you should have a sine function. Okay. So the first 2 pages, in the first 2 pages, they describe how you add vectors, what vectors are. They give you examples of vectors. So this is material that you must have seen in class. For the angle, they give you on page 3, for me it's page 3. They give you the angle, how you get the angle using the arctangent function or inverse tangent function. Okay. You can really do that if the vector, okay, is in the first or the fourth quadrant. Okay. If it points in the second or third quadrant, the arctangent function will not work. Okay. But to simplify, so we'll assume that our vectors are in the first and the fourth quadrant. Now, the procedure.
Sorry, Professor. On page 3, what is the typo error you said?
The typo is on page 1.
Oh, okay. But...
Oh, you mean on page 3? On page 3, On page 3 for the angle, they give you a formula for computing the angle. Once you have the components of a vector, right? They tell you that the angle theta, okay, is arctangent or inverse tangent of the y component divided by the x component of the vector. You see that on page 3?
Yes, yes, I got it. I see it now.
Yeah. So that formula works if the vector is in the first quadrant or the fourth. Maybe I can show you. Let me share my screen with you. Whiteboard. Okay. Let me set up a coordinate system. Okay. Right. So if you have, so this is the first quadrant, second quadrant, third, fourth, right? Because we go counterclockwise. We go counterclockwise always, starting from the positive x-axis, right? Because we're doing trigonometry, right? First quadrant, second, third, fourth, okay? If your vector looks like this, okay? So it points in the first quadrant, then you can get its direction using the arctangent function. If it looks like this, it's pointing towards the fourth quadrant. The fourth quadrant. Then you can get its direction using the arctangent function or inverse tangent. That formula that I was talking about on page 3. Okay. However, if it points in this direction, you see this? Then you see that it's pointing in the second quadrant. Okay, because to know what quadrant the vector is pointing to, you take its tail, so you translate it parallel to itself until its tail touches the origin. So this one that I just drew, okay, if I move it to the origin, it's gonna look like this. You see that? It's gonna look like this. And you see that its arrowhead is in the second quadrant indeed. See that? So then we call this V3. Okay, so that's the same as this one, V3. The arctangent function is not gonna give you its angle. The angle, its direction, which is this. Not gonna give it to you. Okay, because this angle is greater than 90 degrees. And the arctangent function or inverse tangent function will give you angles that are between minus 90 degrees and 90 degrees. Okay, so it's not gonna give you this V3. Okay, it will give you this. So this one, the first one, let me call it V1. Okay, so if you wanna know in which quadrant, towards which quadrant it's pointing to, translate it until its tail touches the origin. Okay, so move it parallel to itself. That's what that means to translate it. Move it parallel to itself until its tail is this, touches the origin. So it would be, look like this. You see, same length as V1 and parallel to V1. That's what the translation is. Same length as V1, but parallel to V1. So this is also V1. And you see that its arrowhead is indeed in the first quadrant. And you see that this one, let me call it V2, you see that it's in, it's pointing towards the fourth quadrant, right? How about this one? Let me call it V4. Toward which quadrant is it pointing? Somebody.
Third.
Third, yes, that's correct. Third quadrant. Therefore, the arctangent function or inverse tangent function will not give you its direction. Okay, it will not give you its direction. I mean, there's just a small adjustment to make. Okay, you have to add 180 degrees. Okay, you have to add 180 degrees after you use the arctangent function. Okay, but that's not the topic of today's session. See there. So the chat room, I think I have. Let me see what they're saying. Yeah, I think I have some issues with my internet connection. So yeah, just let me know and I will keep repeating, okay? Yeah, I have issues with the internet connection. So hopefully, just let me know if this happens again, okay? All right, yes, so I was answering your question about that arctangent function. So now I think we can start the actual lab. All right. So I'm going to explain to you how things work. It's not really hard since you've seen vectors in class. And then I will let you work on it. Okay. So we have about an hour and 20 minutes left. So maybe for half of the time, I will explain to you how the simulation works. And then for the second part, you'll work on it and then you can ask the questions as you go along. All right, so let me stop sharing. And then open the instructions, instruction file, 2, 3 vectors. Okay, let me share the screen with you. All right, great. Can you all see the simulation?
Yes.
Called vector addition?
Yes.
Yeah.
Yes, okay, good, good. So, so we are taught to click on Explore 1D, okay? So I'll click on it, okay? And I get a grid, okay? With an x-axis, okay? So that's what one dimension means. It means that the object or the particle or the object is allowed to move to the left or to the right, nowhere else. one dimension means that the object is allowed only to move along a straight line. Okay. All right. So now, if you have a vector quantity like velocity, for example, all right, how do you tell the direction of the vector quantity? Well, we are going to see that in this part of this equation. So on the right side of the screen, you have to click on values, or check values, on grid.
Yeah, the link is broken for me for the simulator.
Okay, you just follow what I do first. Okay, I think that's the
Okay.
best thing to do now. Okay, instead of doing what I'm doing, okay, because then there will be many questions, you will be lost. So just follow what I do, and once I'm done in 20 or 30 minutes, it will be your turn, and then I can help you out. Okay, but just follow what I do first. Okay. So the grid, okay, it's already checked, and the double arrow already checked. Okay, for horizontal plane or x-axis. So drag the three vectors one at a time from the right side of the screen onto the grid. So they are vectors A, vectors B, one at a time, and vector C. Okay, these are the three vectors. What direction do the vectors point to? Specify positive or negative direction. I think you can answer that question already. Okay. What directions do they point to? Somebody.
Infinitive.
Excuse me?
Infinitive.
Well, they're pointing toward so the direction is positive or direct or negative. When you're allowed to move in only one dimension, then the direction, there are only two directions in which you can move, left or right. But here, we say here we can say negative or positive. So which one of the two is it? Positive or negative?
It's positive infinitive.
So it's positive. It's positive. So all three of them are pointing towards the positive direction. Okay. Okay. So that would be the answer to question number 5. Okay. Now extend one of the vectors on the grid by clicking on it and dragging. Okay. You don't just click on anywhere on the vector. You click on the arrowhead. Okay, like vector A, for example. If I want to make it longer, I click and I drag. Okay, and you see that at the top of the screen, I get the magnitude of the vector, which is 15. Okay, whatever the units are, could be 15 meters, could be 15 meters per second, it could be 15 meters per second squared, 15 newtons. Okay, it doesn't really matter. Okay, the angle is 0. Okay, because this vector is making an angle of 0. Okay, with the positive x-axis. How do I know that? Well, as I told you earlier on the whiteboard, what you have to do in order to find the direction, okay, you have to move the vector or to translate it until its tail touches the origin. So put it on the origin, and you see that what is the angle between that blue A vector and the x-axis? Well, there's no angle, right? One is on top of the other, right? So there's no angle, so that's why the angle theta is 0. See that? The x-coordinate of the vector, that's obviously 15, right? Because that's the length in this case. That's 15. And the y coordinate, there's no y coordinate because we are in one dimension, so there's no y axis. Okay. So extend one of the vectors on the grid, but so I extended this one. I can extend vector b. Okay. Or even contract it, make it smaller. One, extend it. Okay. And then I'm told check sum on the right to determine the resultant sum of the 1D vectors. So what should the sums be? Before we check, we use the computer to tell us what the sum. So if you were to add up all these three vectors, what would you find? Somebody?
You add the x components of them, so you just add the x values.
Yes, that's true. And in this case, what will the sum be in this particular problem?
14 plus 15, 29.
29, that's absolutely correct. Yes, 29. That's correct. That's correct. 29. And then now we can check using sum, okay? And it tells us that's 29. So you see it's 29. So that's the dark blue line, the dark blue vector. It doesn't start here, it starts at the origin. Okay, let me move the A vector here. See, it's this one is 29, okay? Now, so that's the resultant vector. If you were to add them up graphically, what would you do? A, B, and C, okay? To get this resultant vector, this the dark blue vector, which is called S, okay, of 29. Well, you would have to put the tail of one onto the head of the other, okay? So A plus B plus C is, okay, so A is here, plus B, put B here, plus C here. Let me move. You see how I'm translating them? I'm moving them parallel to themselves. That's what translation is. But now until head touches tail. Okay, and you see that the sum of the three, which is this light blue line, has exactly the same length as the vector S, which is the dark blue line. Okay, they have the same length, and they point in the same overall direction toward the positive x-axis. Therefore, they are the same vector. Okay, so this light blue line, this light blue arrow, and this dark blue arrow are the same vector. Okay, so that's why the sum is 29, whatever the units are. Okay, so click erase symbol below the grid to clear the grid. The erase symbol is here. We've cleared the grid, and now we want the vertical. Click on the vertical double arrow, and we have this, okay, as the y-axis. But you see, we have only a y-axis and there's no x-axis. So we are allowed to move only up and down, up and down. Therefore, since we are allowed to move only up and down, we are still in one dimension. We are still in one dimension, okay? An example, and anybody can give me, there's a very good example that you all know about of motion in vertical motion in just one dimension. What would that be? An example.
Is it gravity?
Excuse me?
Is it gravity?
Gravity, yes, gravity, that's true. That's a motion in just one direction. One-dimensional motion, that's true. Another one. So because if you take, I don't know, a coin, for example, and you let go of it, right? It's going to go down and just gonna go down. Right? That's well, gravity, but you have to be careful, okay? When you say gravity, okay? If you let go of something and it goes down, right? And it goes down, then that's just one dimension. It's motion in one dimension. But if you throw something, okay, like a cannonball, okay, cannonball is not going just up or down, right? It's moving in a plane. It's not moving along a straight line. It's moving in a plane, right? So that's motion. In that case, it's moving in 2 dimensions. Okay, and if you take into account the wind that's also pushing it, the cannonball, then it's not moving in a plane anymore, just in a plane anymore. It's moving in a 3-dimensional space. So you have all of that under the influence of just one force, which is gravity. So you have to be careful when you say gravity. Okay, you have to be more specific. Another example is an elevator, for example. An elevator is allowed to go only up and down. So that's vertical motion in just 1 dimension. All right, so repeat step 4 and through 7. So now our vectors are D, E, F. Okay, and then we can extend one of them or 2 of them, it doesn't matter. Okay, and you see that the resultant changes, right? The resultant changes, the resultant vector, right? Maybe so we can see it. Yes. Okay, and to add them up, you add them up just like we did with the previous 3 vectors. Okay, tail to head. Okay. So if you want me to do this, because it's fun to do, and it teaches you a lot about vectors. Okay. So this is E plus D plus F. And you see, it's exactly of the same length as the sum, and they are parallel. If they are of the same length and they are parallel, then it is the same vector. Okay. And see, 3 plus 13 plus 7, that's indeed 23. Okay, and you see that if I click on F, vector F has a y component, it doesn't have an x component, its x component is 0. And its direction is 90 degrees, right? Because if there were an x-axis, okay, and you put vector F at the origin of a 2-dimensional coordinate plane, if you did that, then it would make an angle of 90 degrees with the positive x-axis. But really, in one dimension, this angle is meaningless. Understand? This angle of 90 degrees for motion vertically and the 0 degree for motion horizontally, it's really meaningless. Okay, because you are moving in one direction only. All right, that's good. We're making progress. Are there any questions so far? No. Okay, so now we are going to go to the 2-dimensional part of our simulation. So explore 2D. Okay, I'm on page 4 of the instruction file. So check values. Okay, check values. Check angle. Check the angles. Grid and components. Everything is checked. Okay. Now click and drag vectors A, B, and C onto the grid. So A is here, B, C. Okay, so these are the vectors A, B, and C. Okay. Click on vector B to extend and rotate it until it is pointing into quadrant 4. Okay, vector B. So I want vector B to point in the fourth quadrant. In which quadrant is it pointing now? B.
The second.
No. Is it pointing in the second quadrant? To
I
know,
mean the first. I mean the first.
the first, right?
Yeah.
To know, you translate it until its tail touches the origin. And then you see that its arrowhead is in the first quadrant, right? Remember, this is the first quadrant, this is the second, this is the third, this is the fourth, right? You have to count going counterclockwise, starting with the positive x-axis. The origin, positive x-axis is this. So you start here, counterclockwise, first quadrant, second, third, fourth, like in trigonometry. Okay, good. So that's vector B. How about vector A? Which quadrant is it pointing to?
That's the first.
First. That's correct. To move it, to rotate it, you again click on its arrowhead and then you rotate it. Okay, and then you can extend it, make it longer, make it smaller, anything you want. Okay, this is vector A. In which quadrant is it pointing now?
The third.
Third.
Yes, that's true. That's true. That's good. Okay, so I think you get it. Now we need vector B to point in the fourth quadrant. Here it is. Okay. All right, fourth quadrant. Now we need to sum AX, BX, CX. You add up the X components of all three vectors. Okay, that's very easy to do. So you click on each. So for A, you click on A, and it tells you at the top what the X component is. X is -6. Click on B, it tells you what the X component is, 5. Okay, click on C. Before we click on C, what do you think its X component is? Vector C. Somebody?
Zero.
See, it's pointing downwards, right?
0.
0, right? 0. Click on it, and indeed you find its X component is 0. So if you add them up using a calculator, okay, or on paper, what do you find? That's what question 5 is asking you to do. And then do the same thing for the Y component. Okay. Now question 6 is finding the sum, but using the simulation. Find the sum of the 3, and it's this vector, the blue one. Okay. Okay. We can't really see. It's very long. So maybe let me reduce this. Okay. Okay. And maybe do this. Okay. Now, see, so this is the sum. It's called S. Okay. Because if I click on it, it has, so okay, let's do it. Let's do it together. A was 9, X component was -9, right? B, X component is 5, -9 plus 5, so that's -4. -4 plus 0, so that's -4, and that's -4. You see that the sum is -4 indeed. So so that's the X components. The Y components now. A, I have -3. B, I have -6. -3 plus -6, that's -9. -9, and C, I have -6. So now I should have -15 for the sum. If I click on it for the Y component, I find indeed -15. You see that? We call that, we say that we have added the vectors algebraically. That's what I just did. to add them algebraically. Okay, so you add the components, the corresponding components together. Okay, so that's how it's done, and that's easy to do. Now it's very instructive and very important to know how to add them up geometrically. Okay, geometrically. Well, I'm pretty sure you've seen this before in your lecture, but since now we have a simulation, it's much easier to do than just on the blackboard. Okay, so let's do that and see if we get what we expect. Basically, the blue line, the dark blue line, which is the sum. Okay, how do we add them up? Head to tail, just like I showed you with the 1 dimension, but now in 2 dimensions, it's less trivial and more interesting. Okay, A plus B would be, I take B, the tail of B, I put it on the head of A, but I move B parallel to itself. You see that in moving B, it was always going parallel to itself, right? Now, A plus B plus C, I take the tail of C, I put it on the head of B. All right, do you see that? Now, I don't have a 4th vector to draw, but you have to imagine drawing a line segment from the tail of A, which was the first vector, in A plus B plus C, to the head of C. Okay. So the line would look like this, right? Like from here to here. You see that? You have to picture that line segment in your head. Okay, from here to here. And in that case, do you see that it's parallel to the dark blue line, and it has the same length? It would have the same length. Do you see that? So that's how you add vectors geometrically. Okay, so A plus B is the vector A plus B goes from here to here, and then when you add C to that vector, then you get a vector that goes from here to here, and that points in this direction. Okay, and you see that it's exactly, it's very easy to show you that. I can just take the sum vector and translate it and see if it fits what I just told you about. Translate it. And do you see that it fits? So that's why it's the sum. That's why it's the sum. Okay? And if you want to know why the components of the sum are as they are here, in this case, it's not going to be easy to know. Because you see, it's gonna go off the screen. See, that's the problem. See, that's why I don't wanna use this. But let me use maybe vector B. Okay. So its components are 5 and negative 6. Okay, let me reduce it a bit. Okay, so you see that vector B in this case, its components are 5 and negative 4. X component is 5 because you see if you project it onto the x-axis, then you see it's 5 squares away from the origin in the positive x direction. And its y component is negative 4 because it's exactly 4 units down from the origin in the negative y direction. 1, 2, 3, 4. If you project it, you see you fall at negative 4. Okay, but all of this you already knew from your lectures. Okay, the reason why I'm showing it to you here again is that it's more convenient to show when you have a simulation like this one. All right. So let's keep going. Okay, so we need to click on the icon lab at the bottom of the screen. Are there any questions before we leave this two-dimensional simulation? No questions? Okay, so now the third part. So click on lab, which I just did. Okay. Click on one vector and drag it into the grid. And let me choose the blue one, drag it into the grid. Okay. This vector is V1, so we're going to call it V1. Okay. So we want the magnitude of V1 to be between 5 and 10. Okay. Okay. So we change it. 7.8. Why not? Magnitude here, right? 7.8. So that's between 5 and 10. And its direction to be between 10 degrees and 70 degrees, which it is 50, or I can change it. It doesn't have to be the one given to me. Between 10 and 70, right? Yeah, 41.2. And magnitude is 10.6 and direction 41.2. Okay. Record the data in table 1. Okay. Click on the same color vector as in 2 above and drag another vector into the grid. The second vector is V2. V2 is here. So same color. 2. Okay. Now we want its magnitude to be between 10 units and 20. Okay, so let me extend it. 16.3 maybe. Or maybe that's a bit. 13.5. Direction between 100 degrees and 220. Okay. So you rotate it. 100 and 220. Like here, maybe. You see, it won't give you above 180. Okay, so if you want 210 degrees, you have to go, because it's an angle of the third quadrant. 210 would be about here. So what will it be? 210. So that's a 30 degrees. 150 minus 150. Okay. I can get it, but it's about somewhere here. Okay. Right. That's angle of the third quadrant. So, but to simplify things, I'm gonna make it a vector of. Okay. Oh, sorry. I have to go. The second quadrant. Okay, so, yeah, that's not bad. So then you have to record the data in the data table. And point 4, you have to do that at home. And then show the, and then you have to determine the magnitude and direction of the equilibrant. So that's the vector that's in the opposite direction from the resultant vector. Okay, so the sum. So you have to add them up, find the resultant vector, and then find the vector that's in the opposite direction. Okay, same magnitude but in the opposite direction. Okay, so you have, so that's point 5. So you'll do, when you do that, as for all the calculations, for all your lab reports, you have to show all your steps. Okay, don't just give me the final answer. Show me all the details, all the calculations. Okay. And then part 6 is to record a screenshot. That's all. So part 4. Okay. Application in life. So part 4, so you have to read this carefully and then do that at home. There's no simulation for that. Okay. Are there any questions? It's 8:05. We have until 8:40, so another 35 minutes. So for the next half an hour or so, you'll be working on this simulation. And if there are any issues, you can ask me questions. So, but before then, before you get there, are there any questions about everything we've done so far? Okay, chat.
I have a question.
Yeah.
So for the first 2 parts of the lab, are we submitting anything?
Yes. Yes, of course. There are questions, right? There are questions. They say
Oh, okay, I
so
see.
to add them up, add up the components, okay? Find the sum, okay? You have to, yes, of course, you have to do that. Okay?
Okay. Thank you.
Yeah. Yeah. Of course. And then I see somebody here is asking, so what is the format of the lab? Well, just answer the questions. That's all, just like you did with the first lab. Yeah. That would be enough.
Professor, when can we see our grade for our last lab that we submitted?
I haven't graded it yet, but once I do that, you should be able to see the grades on Blackboard. At the same place that you submitted your lab on Blackboard, at that place, you should be able to see your grade. But I haven't graded them because the deadline is today, right? So technically, the deadline has not passed yet because they do at 11:30 p.m. Okay. Yeah, but so you'll be able to see the grades there. Any other question? Okay. So let me stop sharing and stop recording.